Hi everyone, welcome to the EL6509 project demo online presentation. I'm very happy that to share this project results to all of you guys. Okay, so in these PPT files, there contains what I do in this project and shows the backbone of my project. Okay, let's come to the first slide. So the first part of our project is just how to establish the relay channels using the relay wireless models, relay distribution models. And firstly, I just to come to the background review of the wireless communications, because wireless communication always covers the interference and errors. So there are two common models. One is relay models with path loss contained, and the other is Okumura-Hata models. In this project, I use the first models. And what is definition of the relay distribution? So according to the noise linear system and some of the Wikipedias, I found the density distribution functions as following equations. And then how should we realize to establish the relay channels? Here I use the MATLAB command. I use the function relay channel functions. I listed two functions. The first function is just to rebuild the relay channels with simple path, and the second function is to rebuild the relay channels with multiple paths. The difference lies in the tau and the PDB. And tau is the vectors, that is the path delays that corresponding to each of the path in the multipath. And the PDB is the gain vectors that corresponding to each of the paths to the multipath. Okay, so let's come to the third part of a project. The third part of my project covers three of the important issues that we want to evaluate the quality of the wireless channels. The first term is the path loss. The project gives the definition of the path loss and showed how to calculate the path loss. And later, I show some in different transmitting environments, there are different path loss exponents because exponent. And the second term is signal noise ratios. We come to definition and we come to measure in decibels. And the third term is the bit error ratios. Here I mention this because it is very important to indicate the quality of the communications. So here I provide one of the convenient ways using the MATLAB tools, BER tool command to generate the plot of the BER under different modulation methods. So let's show it in my project. So here is the screenshot of the configuration of the bit error tools. Here we choose the channel type relay channels, and we choose the diversity order 3 as the multipath, and this is just a 64 QAM screenshot, and actually I selected 4 modulation types, and just clicking plot, and we can build the comparison plot of 4 of the modulation method. From these figures, I want to show us that in the same SNR conditions, the lower order of QAM is better than the higher order of the QAM, since the 16 QAM is much better than the 64 QAM, because the 64 QAM's bit error is very high. And during the 4 modulation techniques, BPSK is superior to the other 3. So during the same conditions, we should choose BPSK in this case. Okay, so let's come to the network simulation part of a project. This part mainly consists of two performance simulations. The first is the bit error ratios performance. So here, I just write down the core functions that I use to generate my relay channels and to generate the output given my designed relay channels. And here, uh, using this source code, I get my anticipated results. This columns indicates that I got my relay channels bit error rate outputs, and this one shows the comparison of the relay channels with the AWGN. And actually, so the red plot represent the actual relay channels with multiple delay and multiple gain. And this blue one is just a theoretical relay channels that is the minimum bit error ratios it can reach because it doesn't consider the path loss and path delay. And this is the AWGN bit error ratios. From this plot, we can see that AWGN bit error ratios is much better than the relay channels. But in the small SNR range, I think that these two channels may not be much more different. But when the signal noise ratios goes up, I mean the signal level goes up compared with the noise, then there's a drastic drop in AWGN than the uh, relay channels. So after the big signal noise ratios, I think we should adapt using the AWGN channels instead of relay channels. So here's the second part of my simulation results. So I make the result of the path loss. So here I just to write down the two core functions that I use to calculate the small scale fadings and large scale path loss. And in the project report, we can find this is the result of the small scale fadings and the large scale path loss in numerical. And these two figures, figure 7 and figure 8, make a big comparison. In figure 7, we can find the red represents the large scale path loss and a blue rays represent the small scale fadings. In this plot, we can find velocity affects small scale fadings more drastic than the large scale path loss. Because the large scale path loss distance is very large and it is a dominant factors. So the velocity is not a big problem. It's not a big factor. While in contrast, in small scale fadings, velocity affects the number of the results in a great extent. Well, in figure 8 compared with figure 7, I think there is a big shock that the velocity goes from 30 kilometers per hour to 100 kilometers per hour, and we can find that the small scale fading is more drastically than the original small scale fading. You know that in small distance transmissions, velocity is a dominant factor, and from these two comparison, we can find the case. And the next part is some of the numerical analysis. Just as mentioned before, I just made the same meaning statement in this part and made a conclusion of my project. And the next part is just the perspective on my future work. because there's some incomplete results in my current project work, and I also have another project on the ad hoc network. So I just want to make sure if there's a connection between the ad hoc network on the energy allocation between and the relay channels. So I want to make connection with two of them. So that is the future work to make this project more complete. Okay, so thank you for all of you guys listening to these demos. I appreciate your favor. Thank you. Bye.